Good day everyone. As discussed in the previous lecture, we discussed about the hardware and the main components of the drone. Similar to hardware, the software and data also play key roles while making a drone. Let us understand how the software and the data play a key part throughout this lecture. As drone software is the brain of the drone, we have to explain how it works. Drone software is designed to tell the drone where to go and what to do while flying from A to B. In order to understand and connect all necessary information of the drone, the software part becomes a very complex system. The software installed in the drone operates in a layer-like system. Furthermore, the layers are divided into tiers which perform in various time slots. The layers have to be combined properly to control the flight patterns, altitude, and other important information for drone to work and act accurately. This combination of layers is called the flight stack or autopilot. Many surveys and inquiries have been conducted and they all have a very firm indication. That is, it doesn't matter if the drones have different efficiency or mission complexities. They all need effective operating components. The received information has to be analyzed during the flight. In order to achieve unified components communication, a generic architecture must be designed and promoted. While the onboard system itself is not enough, external middleware and operating system are necessary. The software layers are firmware, middleware, and the operating system. The current slide shows a list of open source stacks. They are as follows: KKM Multicopter, Ardocopter, Drone Code, MultiV, Space Flight, Clean Flight, Data Flight, Space Flight, Paparazzi, Open Pilot Copter Control, Cow Labs, and Crazy Fly. One of the key components of a drone software is mapping and flight planning. The intention of the software is to create a mission for drone, follow whether the drone is carrying out the desired mission, adjusting the drone according to the flight plan, and checking the results of the mission carried out by the drone. The software also allows to carry out a fully autonomous mission of the drone, planning the waypoints for the drone to carry out, pausing and resuming a mission by the drone, shifting between manual and autonomous mission for the pilot, corridor mapping based on the requirement, and the terrain following of the drone. There are many softwares that are commercially and freely available for flight planning. Students are encouraged to find these softwares and keep a repository of information of the software with themselves, as it can be very useful during the course. Once the data is collected from the drone to the lidar or camera or any other sensor, the data is sent to the post-processing software. The post-processing software takes the data and does various operations such as photogrammetry, 3D mapping, object identification, volumetric mapping. In photogrammetry, a drone captures a large number of high-resolution photos over an area. These images overlap such that the same point on the ground is visible in multiple photos and from different vantage points. In a similar way that the human brain uses information from both eyes to provide depth perception, photogrammetry uses these multiple vantage points in images to generate 3D map. Similarly, in some applications, the data from the lidar is taken and reconstructed using the post-processing software to create volumetric data. This is very useful in applications such as mining, where you have to have a volumetric data of every day of how much the mine is being mined and all those things. So I request you to have a look at the different post-processing software that are available online. NPNT software. NPNT or No Permission No Takeoff is a software program that enables every RPA except Nano to obtain valid permissions through Digital Sky platform before operating in India. This has become a requirement now by the government. NPNT requires all manufacturers to implement firmware and hardware changes that only allow flights authorized by DGCA to physically take off. No drone will be able to fly without first specifying to the DGCA its intended flight envelope time of flight, and pilot credentials. These new drone regulations for India are seen as a boon to the growing drone market, as the government believes that drones are the future, and after integrating artificial intelligence, the technology can create more positives than negatives. To streamline the process, the government has created a policy where anyone can use a drone. One of the biggest uses of drones is to use the data that is collected by the drones. One of the most important goals of AI in the drone industry is to make efficient use of large data sets which are collected by the drone. This would mean that data sets were addressed in an automated way without a human in the loop. With the increasing development and spread of drone technology, the availability of high resolution images used for various tasks such as maintenance, surveying, mapping, and monitoring is increasing. There are already many established software companies on the market offering intelligent data analysis solutions to make unstructured drone data actionable and gain meaningful insights without time consuming manual analytics. The present slide discusses about the drone data based decision making. Since the data is available in real time on the ground station, it enables the pilot to take immediate decisions. For example, one of the drone applications where drones are used is drone patrolling and violation detection on roads. What happens is that the real-time video that is coming from the drone is used to detect whether there are any stationary vehicles on the side of the road or whether there are any violations done by the vehicle. As soon as as soon as it is detected that there is a violation happening, the pilot can be immediately informed and the drone can be taken to that particular vehicle. Similarly, in firefighting applications, the data coming from the drone will help the firefighters analyze conditions where there is critical requirement for saving people or where the structure is going to collapse. These kind of drone-based data decision processes are becoming a need of the hour where an immediate decision is required from the drone data. Thus, in this lecture, what we learned is about the drone software, the mapping software, the post-processing, and the NPNT software, and we learned about the drone data and the data based upon the decision. Thank you very much.